Hi guys, and it's been a long time since I have uploaded my last video regarding our series topic in Calculus 1. So for today's topic, we will be discussing about derivative. So this is actually the main course objective of Calculus 1. So why do we need to learn derivative? Well, of course, you'll be using this especially for those engineering students. So you'll be using the concept of derivative from on your entire life as an engineering student actually. And aside from that, actually derivative is very useful when it comes to our daily life activities, say for example optimization, and we'll be talking more about it in our future discussion. Before we solve on complicated problems about derivative, let us learn first the definition of derivative and its very basic formula. So let's start and have our discussion about the definition of derivative. So first, the definition of derivative states that the derivative of the function f of x with respect to x is a function given f prime of x. So this is actually the symbol. This is one of the annotation of the derivative. So if you see this f prime of x, that means the first derivative of the function f of x. And this is actually defined as f prime of x can be calculated, or let's say the derivative of the function f of x can be calculated using the formula f prime of x is equal to the limit of the function f of x plus h minus the function f of x divided by h as h approaches to 0. So let's apply that one on a certain example problem. So say for example we wanted to calculate the first derivative of the function f of x, which is equal to 2x raised to the power of 2 minus 16x plus 35. So applying the formula on our previous slide, the derivative of the function f of x is defined by the limit of the function f of x plus h minus f of x divided by h as h approaches to 0. So applying the formula on our equation, so f of x plus h, so that simply means that we will convert all x into x plus h. So you can see here, substitute lang natin yung directly on the x's. So then minus the function f of x, so this is the function f of x, so we simply plug that one here divided by h. So from this one we can simplify this one, combine like terms, and we'll obtain this as the simplified form of this equation. Now, as h approaches to 0, so question, can we directly plug 0 into the equation? Is it possible? Well, yes. So we can basically evaluate the normal limit directly by plugging 0 in the equation. So by doing that, we'll obtain this 4x minus 16. So therefore, the first derivative of the function f of x is equal to 4x minus 16. So very nice and easy. So that is how we are going to apply the very basic formula of derivative. Okay, so let's have some theorem regarding the derivative. So we have here the function, or a function f of x is called differentiable at x is equal to a if the first derivative at a exists, and the function f of x is called differentiable on an interval if the derivative exists for each point in that interval. It says also that if the function f of x is differentiable at x is equal to a, then the function f of x is continuous at x is equal to a. So maybe in the near future you will encounter some problem in your calculus, or maybe any type of problem, and the problem is asking you, and you're given with the equation like is the equation continuous at a certain point. So to evaluate that one technique is using this theorem on derivative. So you can find the first derivative of that function or equation and then evaluate that derivative if the derivative exists at that certain point. Okay, so for better understanding, let's have an example regarding this theorem. Say for example, we wanted to know if the function f of x is equal to the absolute value of x continuous at x is equal to 0. So using our theorem, we calculate the first derivative at 0. So we have the formula f of x plus h minus f of x all over h. So in this case, we set x is equal to 0. Okay, so simplifying this equation, we will have this one, and then further simplifying this, we will have this one. Okay, now question, can we directly evaluate this normal limit? If we try to plug h is equal to 0 in this equation, as you can see, this will be undefined, right? So basically, we cannot do that one. Alright, so how do you think we're going to deal this type of problem? Well, if you remember, we can actually use the concept of one-sided limit here, right? So we can evaluate this equation using the left-hand side and the right-hand side limit. So first, let's evaluate this one on the left-hand side limit. So that means left-hand side. So it should be the value less than 0, but it should be approaching to 0. So value less than 0 is always a very small negative number, right? Okay, so that means if we are going to set the the h is equal to a negative number, so that means when h is a negative number, the absolute value of a negative number is always positive h. Divided by a negative h, we will obtain a negative value, right? So absolute h. So if we are going to find the absolute value of a negative number is always positive, divided by a negative h, we will obtain a negative 1 as the answer. Okay, now let's have the right hand side limit. So absolute value, so right hand side means a very small number, but it should be positive. So that means the absolute value of a positive number is always positive, divided by a positive h number, then h divided by h is simply equal to 1. So as you can see here, the left hand side and the right hand side limit is not equal. So take note from our previous discussion about one-sided limit. To evaluate a normal limit, if the left hand side and the right hand side limit is not or are not equal, that means that the normal limit does not exist, right? So basically, if this limit of h over the absolute value of h over h does not exist, then the derivative of the function at the function f of x, which is equal to the absolute value of x at x is equal to 0, also does not exist. So basically, class, that means that the equation, the absolute value of the equation, the absolute value of x actually does not exist, or it's not continuous at x is equal to 0. So I guess that's all for today, and in our next discussion, we'll tackle more about some shortcut techniques in doing some derivatives. So hopefully you'll be joining me on my next video. So I think that's all for today. Thank you for watching. Bye bye.